chemistry homework hard.
Oh boy, you betcha.
Golly gee, I sure do wish someone could help us.
I know, but there's no one around to help.
Wait a minute, I know someone. Igor the chemist!
But how do we get there?
With our imagination.
Oh boy, I hear the Chemistry Express coming. Let's hop on.
All right.
Yeah.
We're here!
Well, hello, children!
Hi, Igor!
Come on in! Welcome to my home!
Thank you!
Oh, girls, you've caught me in a little experiment. What's the first rule of chemistry, ladies?
Safety!
That's right. And if you hold on, I'll pull this little mixture into here. It makes blue! So, ladies, what did you want?
We're having problems with our chemistry homework.
Yeah, we need to describe the relationships of groups, periods, and periodic nature of the elements of the periodic table. Can you help us?
Well, you need to be more specific. Do you mean like trends or bonding or what do you want from me, woman?
We need to know about trends of an atomic radii.
Oh, jeez.
Well, it decreases going across the table because the atoms, they get smaller and more condensed. And whenever you're going down a group, it increases. Can you tell me why this happens?
We don't know.
Well, as you go across the table, the effective nuclear charge increases, and this is because the number of protons increase, and since the protons act as a whole unit, their charge increases, which pulls the electrons closer. Groups are different, though. Whenever you get into a group, as you go down the table, the energy levels increase, which provides a sort of shield, blocking the power from reaching those, and therefore they seem to get larger because the electrons can go further out because they have more flexibility within the whole atom. Anything else?
What are groups, really?
Well, ladies, as you can see from this periodic table, groups are the vertical rows, and they share physical properties, some chemical properties, some don't, and the noble gases, for example, hold more than one physical property, and they share the same ending electron configuration notation, and just stuff like that. It's very simple, very simple.
Well, can you tell us more? What about those row things, the horizontal ones?
Hold on a second. Periodic table, come back! Well, really, all the periods or families, they are sometimes called families. It's whatever one you like, Jasmine. Do you like periods or families?
I like families.
Then we'll call it families. All families really do is show that the increase in the atomic number, which is the increase of protons and electrons, and the differing electron configuration notations. So it's like it ends in S1, S2, and then you get to P block, and P1, P2, and stuff like that, really.
Oh, that makes more sense.
Yeah.
So, what about ionization energy?
I'm kind of stuck on that one. Do any of you know?
Well, I think it's the most energy needed to take out the outermost electrons from atoms. Is that right?
That's right. But what trends of that are found in groups and periods?
The trends is whenever the family is completed, a large decrease in ionization energy occurs.
That's correct!
Can you tell us more about atomic radii?
Well, as you go down a group, the radii increases because the ECN gets weaker, allowing the electrons to go further away from the nucleus. But as you go across a period, the ECN increases, pulling the electrons closer, decreasing the radius of the electron. So that's pretty much anything you need to know about atomic radii.
Thank you.
Well, before I go on to bonding, which we will get to, do any of you guys know what electronegativity is? It's rather important.
Well, according to my notes, it says that electronegativity is a measure of the tendency of an atom to attract a bonding pair of electrons. It also says, excuse me, Jasmine, I think that's quite rude of you to put your paper in front of mine. Anyway, it also says that it increases across a period and decreases down a group.
That's right! Very good. Now we can move on to bonding.
Like bonding?
No! With chemicals and atoms and electrons. Well, one kind of bonds are ionic bonds. They tend to be soluble in water, they have high melting points, and whenever they crystallize, they're in sharp defined states. You know?
I know.
Okay. Well, one trait of ionic bond is whenever the electrons are transferred, they are actually transferred, unlike covalent bonds whenever the electrons are shared. So let's take one element. What's an element in group 17, for example? Anyone know? Anyone know? And no one? No one?
I'm not sure.
Let's take fluorine, for example. How many electrons does fluorine have? You don't know? Okay. Well, it is in group 17. So
it has 7.
It has 7 what? Ending electrons.
That's right.
Very nice, very nice. And how many electrons does it need to reach a noble gas configuration?
8.
8. And what is a noble gas configuration? S
P26.
No. S2P6.
There we go.
Very good.
Told you we needed help on our homework.
So an element such as lithium, for example, whenever it reacts with... By the way, how many electrons does lithium have?
1.
3. And it has 1 ending electron.
That's what I meant.
Very good, Jasmine. Sure you did. And so whenever the electron is transferred to fluorine, they both have a full ending configuration notation, which means they are completely stable. And they love being stable, don't they? Don't they, Jasmine?
They do.
Yes, they do.
Can you please tell us more?
We need to know.
Okay, let's start with ionization energy. Okay, so whenever you write it down in an equation, it's usually metal and non-metal. This is because the non-metal usually receives the electron because it has a greater effective nuclear charge, and that's why it's usually smaller. And whenever its ionization energy, which is usually quite large because it's so powerful due to that effective nuclear charge, pulls the electron away from the metal, its radius, its atomic radii, increases because it's receiving another electron and it has to fill up its energy shell.
Anything else?
Yeah, actually, a funny thing happens. Once that electron is transferred, that increases, and its effective nuclear charge is lessened because of that. And so, the one over here, its size has decreases because it has basically lost an energy level. Because it still has the S2P6, just 1 energy level less. And so this is more powerful than what this is now. And so electron tries to transfer, but it can't exactly because it increases, and since this is losing power because it's spinning it on that electron, this gains more power, so it pulls it back, which creates a form of vibration, because as this electron moves back and forth, one increases, and they end up doing this, back and forth, making a vibration in most ionic compounds. Wait, not most, in all ionic compounds.
Jasmine! Jasmine, wake up! I think she's dead.
Well, I guess it's time for some experimenting!
Jasmine, come on!
Come on. Let's go. I think he's coming. He's coming.
Wait! No! Come back! This is the best part!
you're smiling,
when you're smiling,
when you're smiling,
when you're smiling,
the whole world smiles at you.
smiles at you.
And when you're laughing,
When you're laughing,
when you're laughing,
when you're laughing,
all the sun comes shining through.
shining through.
When you're crying,
When you're crying,
you bring on the rain.
bring on the
Stop
rain.
your sighing,
Stop your sighing.
won't you be happy again?
Happy again.
When you're smiling,
When you're smiling,
keep on smiling,
keep on smiling.
and the whole world smiles with you.